Welcome to Weathered Questions, where we answer the questions on your radar.
Well, welcome into another episode of Weathered Questions. Thanks for joining us. This is the podcast where we answer the meteorology questions on your radar. My name is Jan Kaj, joined by Kai O'Mara, and we have some great questions queued up here this week as we are headed into the dog days of summer. Very toasty.
It's hot.
It's
really hot.
It really is. It's just not comfortable. I don't care if you're somebody who loves the heat and likes the heat. It's no matter what, this is uncomfortable.
Unofficial report last weekend.
Yes, please.
Forsyth, Montana, 118 degrees. If it stands, it's a new state record.
That is
stupid.
Yes, I was
it
trying
is.
to decide which word I really wanted to go with, but that's probably the.
Yeah, big heat week coming up here across much of the country. And it's not, we're based in Iowa. There's no secret there. And normally we like to spread our wings and get everybody involved, but everybody's hot. So definitely worth talking about it for sure.
Yeah, absolutely. Well, as always, we invite you to ask your weathered questions, or maybe not so weathered. Maybe it's just a question that just popped into your mind right now. Hey, we're still happy to answer it. You can send those questions in to weatheredquestions@gmail.com. Type out your question. You can record it and send us an audio file. Hey, type it in Wingdings and we'll figure out how to decipher it or something if you really want to. But we did get a question this week on our email from JG. He says that, hey, I enjoy listening to your radio broadcasts. Which, by the way, if you didn't know, we are on the radio in Eastern Iowa, as well as finding us on your favorite podcast platform. So lots of places you can find us. But JG asks, how is the normal high and low temperatures for a given date calculated? I know that 30 years of data is used, currently 91 to 2020, and that normal high and low temperatures are not derived simply from calculating a arithmetic.
Math,
what is the word? Arithmetic? I don't know.
Yes.
Mean. Is that the word I want?
Average. Yes.
Yes. Well, words. Yeah. So they're not the average. They're not calculated from the mean. But he hasn't been able to find the calculation. Can you help me out on this? So Kai, can you help him out?
It's a great question.
Can you help me say words first?
And I know what they're thinking in this question, because it's true. If you go through and you take every July 2nd and average it all out, it's going to be different than July 3rd, and it's going to be different than July 4th, and it's going to give kind of maybe an up and down valley. Probably not a huge amount of variance, but it's not like the way that you see it in climate records, where the first of the month is always the coolest, and then the 31st is always the warmest, if you're in the warm season, and then the cool season, the first is always the warmest and the 31st is always the last. And usually it's going down at these steady incremental rates. So this is really a loaded question. This question could take off into its own episode, but we're not going to do that. The truth of the matter is, I'm not fully sure.
We did have to do some research on this one.
Yeah, I'm not fully sure. I've got a theory, though. And it is backed up by a couple of National Weather Service pages, as well as the National Centers for Environmental Information, where not only do you put the averages together in various towns, but there are other observation sites. Maybe they only reported 20 days out of the month. And then maybe last year, maybe they only reported 10 days out of the month. And what happens is you start to kind of blend this available data together. And I know there are thousands of weather stations that go into the calculation. And one cool thing, JG, is do a Google search for Oregon State Prism. And it's prism, just like you would, see a crystal somewhere that breaks light apart. Prism, PRISM. And they've got beautiful maps of all the normals. And what you're going to see is what I'm trying to captivate in your mind here. What I'm trying to say is things are normalized and smoothed out over time. Yes, if you go day by day, there's going to be a little variance. But then if you switch cities and do it again, there's going to be a little variance. And then if you go north 50 miles, there's going to be a little more variance. And then, per the World Meteorological Organization, the average temperature needs to be the daily high and the daily low and average that. And then you do that for every site. So there's a whole lot of mathing going on and some smoothing. And I think at the end of the day, some interpolation going on too. The bottom line though, and I think this kind of springboards into another question, what is normal?
Mm-hmm.
Because I can proudly say, Jan, that I've lived through 3 normals.
Yeah.
I have. I've lived through 61 to 90. I've lived through 71 to 2000. Actually, 4 normals. Oh my gosh.
I was going to say, you should have one more than I do.
I've at least got 4 normals in me.
Yeah.
But at the same time, like it's my life so far. And I do know that they try to pick 30 years as kind of a baseline to get some of the extremes taken out so that you can see trends. So for example, if you did a 100-year normal, you're not going to see hardly any extremes at all. It's just going to be one big block. And then you'd have to wait another 100 years to do another one. So they choose 30-year blocks every 10 years so they can pick up on the trends. Quite frankly, I think the better tool is to get yourself a line graph. And if you're curious how the July temperatures have changed over the last 50 years, there are ways to plot that out. And you can actually do that visually with Prism too. And you can see, like, have we cooled a degree or two in the last 50 years? Have we warmed? I can tell you the Midwest has actually cooled a little bit. You wouldn't know it this week, but we've cooled a little bit for daytime highs. Other parts of the country have warmed a lot, you know? So that's the answer to that question. And like I said, I'm better than 50-50 on it. I don't think I'm exactly right though. I think I'm better than 50-50 to at least get us going down the right path on that one. That's a loaded question for sure.
It really is.
Doubt.
And to your point, there's so many different things that go into it. And with the 30-year average, it is a moving target, right? Like
absolutely
every decade, it's a new normal.
Right.
And so that does change, that does adjust. And so it's a moving target, and it's all it in your entire lifetime, right? Every decade of your life, it's going to be a little bit different. And I think all of us can think back to, well, when I was a kid, we didn't have, whatever, right? We had snow that we could go sled in, or we didn't have this kind of rain, or whatever it is that you want to say, because that set of normals is constantly moving, is constantly changing as the natural world is changing.
Right. And, the biggest change I've noticed, at least in the Midwest and in my lifetime, is what seems like the delay of seasons phenomenon, where winter is dragging on a little longer. Mm-hmm. It's taken a little longer to get into summer. Fall has been warm lately. September is clearly a summer month. Yes. And then we're not getting a ton of snow really till we start getting into December and, getting snow around Christmas time. It's not like the amounts have changed. They've just shifted slightly. Mm-hmm. So that's an interesting thing to take note of too. But
those white Christmases are harder to come by. It seems.
They are. Well, and to your point, Jan, if you constantly move the target, then why bother? If you constantly move the target. But the reason why the normals are there is to give a baseline to especially energy companies, farmers, to figure out, where do we start to see, issues? How far above the norm is this? How far below the norm? Here's my general rule. If we're plus or minus 20 degrees from the normal, that's a significant event. If we're plus or minus 25 degrees from the normal, we're probably at record territory now for potential record highs or record lows. So I think it's a good way to think about it. If we're plus or minus 10, that's noise to me. 15 and 20 more substantial. 25 is probably close to record most times.
I think that's all fair.
So that's my little rule. It doesn't work everywhere, but that's my little rule. But speaking of rules, there are rules in meteorology that have to do with physics and water and air. And Jan, we've got a question in. This comes to us from Reese in Altoona. Can you just remind Reese what the dew point is again, please? For all involved.
I would love to. And some background on this question. Reese is a coworker of mine, and he poked into my cubicle the other day, and he was like, okay, what's the dew point? I can't remember. Like, I need you to understand it. And I was like, I am so glad you asked. And I was genuinely so glad, because talking about dew point, I think as a meteorologist is something that we all truly, truly enjoy, because it is a very misunderstood parameter and something that we use a lot and the general public uses a lot, even if they don't realize it. So the science-y version of it is that it's the temperature basically that you have to cool the air down to in order to get water vapor to condense out. So that's the fancy words, right? I could come up with even fancier words. I'm sure Dave Flory, if he was listening, he would be I remiss that I do not remember the exact definition on my note cards from my classes, but we had to memorize all those fun definitions, right? But essentially what it is it's the amount of moisture that's in the air, is the really basic understanding of it. So as the temperature changes, the dew point is also going to be changing. They're both kind of fluctuating with each other, but when they become equal, that is when you would get something like dew. That's why it's called a dew point. So, if the temperature overnight during, a summer evening, maybe it cools down, temperature and dew point become the same. That's where you're going to get moisture on all the grass around. Maybe if you were out camping or out at a bonfire or something, that's when you would notice that. So how we use it is a measure of comfort, honestly, during the summer. For us in the Midwest, where we have plenty of moisture and crops and everything, pumping even more moisture into the air, the higher that dew point is, the more uncomfortable it's going to be. So if you have a dew point that is generally for the Midwest, if it's in the upper 60s, that's where you're really starting to feel, it feels pretty humid out. Once you get past that 70-degree mark, that's where it becomes uncomfortable. If you make it up to 75 to 80, that's, I wouldn't say unheard of. We have seen it. It does happen, but it's soupy. It is air you can wear at that point. So that's kind of the, 65 to 70 is, it feels pretty humid. Feels like, oh yeah, if a storm popped off, it could really do something. You kind of just have that intuition, when you start to get humidity like that. Beyond that is where it is just uncomfortable, really. Below that, generally a little bit more comfortable. So if you have dew points in the 40s and 50s, really you don't have many concerns usually. Now, again, that's speaking as a born and bred Midwesterner, maybe somebody who's out in the Pacific Northwest who doesn't deal with as high of humidity. Maybe you would notice it a little bit sooner into the lower 60s or something like that, just because humidity does impact you differently when you're not quite as used to it. But that's kind of the general synopsis of it. Basically, amount of moisture in the air.
The thing that's interesting about dew point, this is kind of why the koozie came out. And we'll give koozie credit for being a brand name, but
yep.
When you take a cool beverage out of your fridge, let's say it's a 40-degree can, right? Set it outside, the dew point is 70. Immediately what happens is you start forming water beads on the outside. Mm-hmm. You are taking the water vapor in the air, cooling it below the dew point and forcing the condensation to happen. Interestingly, and anybody listening to this that's currently in high school, you're going to learn about this. For those that went through high school, you learned about it, but you may have forgotten it. If you if something goes into a condensation state where it goes from a vapor to a liquid, it's going to release heat when that happens. We call that latent heat. It's like hidden heat, but once it happens, it starts warming things. So I would dare you to try an experiment on the next real humid day where you are. Get 2 cans of root beer, your beverage of choice. Put one in a koozie and leave one open and set them outside on the back porch or whatever for 6 or 7 minutes. Come back inside and take a drink out of each one. The koozie is going to be colder, not because it insulated and kept the pop from leaving. It just kept the beads from forming. So that's your physics lesson of the week. Right there.
There you go.
Yeah. Higher dew points cause a lot of sweat to happen on that. And it warms stuff up quickly. Like it's a measurable amount. It's several degrees.
And that's an important thing to think about. So many times we talk about people are, the heat doesn't bother me. It doesn't bother me. Right. And to an extent there, you can get accustomed to those things, but at certain dew points when you are not able to physically sweat off and to make yourself comfortable, that is where it gets genuinely dangerous. And that's why, as meteorologists, again, we focus so much on the dew points, which go into that calculation for something called heat index, which I know a lot of people have heard about, right? All of that kind of goes together to talk about why extreme heat might be so dangerous as compared to just, quote unquote, a dry heat.
Yep,
so
sure is.
Yeah, it all goes together.
Mm-hmm.
All right, we're going to move on, switch gears to another fun type of summer weather. We're going to talk hail. But before we do that, let's get into today's trivia question, also appropriately about hail. True, false? Got a 50-50 chance on this one. Hail is measured by automated NWS or FAA weather stations. So NWS, National Weather Service, FAA, airports, Federal Aviation Administration. Is it true or false? Hail is measured by automated NWS or FAA weather stations. We'll give you a second to think about it. We'll be back with the answer in just a few.
All right. Hopefully you've had a chance to think about this one. And I hope this one stirred some debate as well. So here we go. Is it true or false? Hail is measured by automated NWS or FAA weather stations. The answer, 99.9% of the time, is false. It is false. However, the key word there that Jan talked about was automated, meaning that there would be no human there to see it. Now, if there is a human observer at the airport, they can do something called an augmented reading. And they can put in the hail code, which oddly is GR, capital G, capital R, and then they'd put a size after it. And then typically at the end of these airport reports, they're called METARs, Meteorological Aerodrome Report, they'll put their initials as the observer. And in my line of work, I actually called an airport once and asked to talk to the observer who was on shift for a storm, just to try and make sure that we had all of our ducks in a row as to when the storm hit and what the impacts were. So automated 99% of the time, the storm's just going to pass by. But that 1%, when you've got a human there, they can go in there and they can manually add it in, and then it goes into the official weather records. So not only are the local storm reports...
He was probably floored that he actually got a call about his hail report.
Yeah. They are. They're usually very like, what are you talking to me for? I got an airplane to get in here. Like, I'm sorry, I'm going to take a minute. That's all I'm going to take.
Yeah.
But then we know. So,
but that is, it's important, like you said, to note that word automated, because an automated weather station, which is what so many weather reports come off of, when we're getting our rainfall totals, we can report those really quick. But hail, you need somebody to actually be there. And so getting those reports is why you always hear your local meteorologist saying, hey, tell us what you saw, send us your pictures, or send us a report, a measurement, and why we need those pictures with the, a dime or a nickel or whatever it is to show, because we don't have any other way to get that information.
Yep. And your true false was very good because it had two keywords in it: measured and automated. Rarely do those two go together when you're talking about a physical size of something. So
yeah. Other fun fact with the automated weather stations, sometimes middle of July, like it is right now, you will see a snowfall report or something like that on a station.
Yeah. Yes, you will.
Generally speaking, in the United States, where many of our listeners are. Obviously, we have lots of listeners from around, but for those unfamiliar, July, U.S. summertime, right? We do not get snow usually in July. What's happening is it's maybe hail hit that area and it registered as a snowfall report. So sometimes we get kind of funky data like that too that'll come in, which is why, again, you can't always trust that automated weather station and why the human meteorology component is so important.
You get a truckload of pea-sized hailstones to hit some sensors, and they're probably going to be confused at the end of what's going on there. They might think it's sleet or something. So speaking of hail, how does it hail when it's so hot in the summer? That is our next question for you, Jan.
All right. I love this one too. Because it's cold in the air. That's how.
Yeah, exactly.
So, where hail is forming miles and miles and miles above the Earth's atmosphere, up in those big clouds, in those updrafts, the cumulonimbus clouds, it's freezing or below freezing. And so that's what's happening, is it's forming in an area that's really cold. And sometimes, usually it's hard to get super, super big hailstones. It does happen. But that's why a lot of times, as it's going down through the atmosphere, it will start melting. And so maybe you'll hear somebody say, this storm has tennis ball sized hail. And by the time it gets to the ground, maybe it is a little smaller, still probably enough to do some damage. If it was a tennis ball up in the atmosphere and is falling more as, a quarter or slightly larger than that. But that's usually what's happening, is it's forming in the cold. It's generally falling down through fairly cool air, not able to melt a whole lot on the way down, but is still doing a little bit of melting. And maybe it'll be a little bit more of that wet hail versus the drier hail that you might get in the cooler months, I guess.
Yeah, because you're gonna and don't forget, you're gonna hit that muggy air too, which against that cold surface is gonna make it all water coated. So it does happen. I mean, 2/3 of a thunderstorm is below freezing, at least, sometimes more, depending on where the storm is affecting people. So makes total sense. Absolutely.
Yeah, even on the hottest days of summer, almost all of our precipitation is starting out as frozen precipitation. Hottest day in the middle of July in the United States, again, it's probably going, well, honestly, just pretty much most anywhere around the world, except for right around the equator, maybe. Pretty much anywhere. It's going to be starting off as snow at the very, very top and eventually falling down then and melting. And that's when you might get rain, or it might, still be hail or something like that. But starts off frozen.
Yep, you're absolutely right. Even during this large heat wave at about 20,000 feet, it's around freezing, if not slightly below right now. So even on these really hot days, halfway up the atmosphere, it's below freezing, and only gets colder from there.
I was going to say, it's only halfway up.
As you go up to that jet stream level, it's just going to keep on cooling all the way through there. So,
all right, this one, I love this question, and I know we've both been asked it, Kai. It's come across before. A flood warning comes across, and it says it's a real flood. A real flood?
Yeah.
Areal. What is an areal flood, and why does everybody think it's a real flood?
Well, here's a good way to think about it. So the typical flood warnings we're going to see right now, you've got river flood warnings that the National Weather Service will issue. You've got flash flood warnings. The key word there is flash, happens quickly, like a flash. Areal has the word area in it. And these are much more slow developing flood situations. They're typically not life-threatening by any means. What they are is standing water in a cornfield, standing water maybe in parking lots or shopping malls or somewhere where it's at least enough for you to notice it. Now, if you go venture into it, that's a different situation. We don't recommend you do that. But it's when low-lying areas fill up with water. And it's enough to be mindful of. In agricultural states, you'll see this a lot in cornfields, especially low-lying corners of the field may get pretty backed up with water. But then once it starts washing things out and going quickly, it is a flash flood at that point. Areal is also spelled like the word area with an L on it. A mutual friend of ours, Jan, got a nasty voicemail talking about it's Arial. Incorrect.
That is another way to spell Arial.
That's the font in
but
Microsoft
not this
Word.
One.
That is not the flood warning. So shout out to our buddy Chris Kubal in Des Moines for fielding that lovely voicemail in his weather inbox. So one of the last TV broadcasters in my class around now. So he's still out there, still working hard, and still dealing with very weird things like a real flood.
A real
AKA
flood.
areal flood. So think about that. It's lower impact, but covers a larger area. Might take a while to dry out if you have an areal flood warning in your spot.
And lower impact, again, to the extent of it's not going to be, fast moving water necessarily, but anytime you don't want to be in floodwaters,
Right.
you don't want to be, playing in them, driving through them, anything that way, it can still not be a good situation. Water can still carry a lot of gross things in it. It can still carry electric current, things like that. So,
and you'll underestimate the depth almost every time.
Yes.
So just stay out of it. But that's what an areal flood warning is. The creeks are coming up, ditches are starting to fill up, that sort of thing. So, all right. Well, that brings us to the end of another episode here of Weathered Questions. Hopefully you've had a chance, if you were driving around town listening to us, to stop by a local lemonade stand, because if there isn't one out there, there should be, because of how hot it is here this week. And again, we'll have to just see if some of these official records drop in the northern plains, but there's been a lot of 100-degree temperatures here the last several days. So seems like it's just going to continue for a bit. But for myself and meteorologist Jan Reiher, don't forget, you can always submit your question to weatheredquestions@gmail.com. Also, JG, I hope we answered your question well enough. Like I said, it's not 100%, but it's as close as we can get you. As close as we can get you here on this episode. So we hope to hear you again next week. Take care and stay safe.